Hello everybody, welcome to our 2017 February Hangout, February 2017 Hangout on advanced OpenVPN concepts for pfSense 2.4 and some for 2.3.3. A lot of things will apply to both, but there's some new stuff in 2.4 I want to go over as well. So about this Hangout, first, this is going to be primarily a presentation discussion. I'm not going to have a complete demonstration for each topic. I might show you a couple of screens of a few things, but I'm not going to walk through anything specific because there's a lot to cover. Many of the things we're going to talk about, they're going to be useful for multi-WAN, but also remote access setups or with VPN providers for internet access. We just did one on VPN providers a couple of months back, but there shouldn't be too much overlap here. I'm going to talk about project notes like I always do with our news and everything for the month. We'll talk about the OpenVPN improvements in pfSense 2.4 and OpenVPN 2.4, the OpenVPN device modes, talk about tunnel network behavior, routing methods, assigning OpenVPN interfaces, and how and why, multi-WAN redundancy tactics, how to use client-specific overrides, talk about sharing the LAN subnet, so an alternate tactic to bridging. We'll talk about how to set up a remote access tap bridge very briefly, and then I have a couple of little tips and tricks. So this month for our project notes, 2.3.3, our pfSense version 2.3.3 has been released. If you haven't heard about it yet, it's up and ready to be downloaded and updated now. It's primarily security patches and bug fixes, but there are some other features in there as well. This may be our last pfSense 2.3 point release. We're going to be doing some errata releases and security updates as needed. We're going to continue to do that after the 2.4 release because 2.4 doesn't support NanoBSD or i386. So we're planning on doing, maybe about a year of support after 2.4 release for 2.3, to give people a transition period to get off of the older hardware that doesn't support the 2.4 release. We've been doing some work on translations and they're really taking off. We switched over to Zenata, I'm not sure how you pronounce that. It's a different translation collaboration site. So if you want to help us to get a language translated that we don't have yet, read that blog post and help out. We have some that are complete or nearly complete, like the two Chinese variants, the simplified Chinese and the one for Taiwan. Those are 100% complete. Spanish is nearly complete, and Germany is pretty far up there too. Brazilian, Portuguese, Turkish, and Russian, those are pretty well complete, or they're on their way to being complete. I don't know if all of those are going to make it for 2.4. The guys we have working on Russian said it might take a little bit too long, but we'll see how it works out. We're hoping to get more languages in. So if you'd like to see your language in there, sign on and join up and help out and get translating. Some of you may have heard about a clock signal component issue with some hardware. All the information we have is up on the blog, and we're going to update that as we get more information. So if you're interested in that topic, you check out the blog. We do have a public Slack channel available, which works sort of like IRC. It's just a real-time chat type program, a group chat. So if you're not familiar with Slack, there's a Reddit post where we went over what it is and how to join up. Sort of like IRC, but we're still in IRC on Freenode. It's just an additional way for community collaboration. There's also, if you haven't heard about it yet, there's a Let's Encrypt package we've got it on pfSense 2.4, 2.3.3, and 2.3.2 patch level 1. So that lets you obtain a free SSL certificate through the Let's Encrypt project. Those are only valid for 90 days, so the package facilitates, authorizing the certificate and validating your identity and whatnot, and then it will also automate renewing that when the time comes, so you'll have a certificate on an ongoing basis without having to think too much about it, past the initial setup. And it supports lots of different methods for updating, including NS update like RFC 2136 DNS style, does SFTP or like SCP style web root, has many DNS providers. There's a standalone method. Can hook into hot proxy and or HA proxy. You can use it for the GUI certificate, which you'll see on what I've done for this month on my the VMs I use for demoing. I've got them set up with certificates, and you can see I've got like the nice green check mark saying that they're valid, and I didn't have to hack that at all. Also on Twitter, our pfSense handle on Twitter is past 10,000 followers. So if you don't follow us yet, join the party. We're also doing some get to post conversion on 2.4. Anything that makes a state change to the GUI, like deleting or disconnecting or reconnecting or something, or making a state change or a config change, is going to use post instead of get. We've had some security issues with that in the past. Going to post is going to prevent CSRF issues because we have the CSRF magic library that helps there. It also protects against accidental changes. If you followed a link, or like if you clicked a link to delete an item and then maybe you accidentally refreshed the page or went back to it, you might have accidentally, erased an entry you didn't mean to, and that's all going to be a thing of the past. So we're going to be pretty well set there once we get all that done. And the conversion, I think, is done for everything except the traffic shaping section, which I'm not quite sure about the status of that at the moment, but it's working pretty well. We're still testing it to make sure that there weren't any regressions with the behavior, but it's been pretty good. All right, so let's talk a little bit about what improved in OpenVPN 2.4 and pfSense 2.4. One of the primary things you can do now is the AEAD ciphers, AES-GCM. That can be accelerated by AES-NI. It's usable in SSL TLS modes. It's not usable in shared key modes. And it's faster because AES-GCM combines the authentication with the encryption, so it's all in one algorithm, so you don't need a separate one. So you have like AES-256, you'd have AES-256, and you'd also have like SHA-256 for authentication. No, this is all done in one step now. Now, OpenVPN still uses the authentication digest algorithm for the control channel, but it doesn't use it for the data channel when it has AES-GCM. So it's going to be quite a bit faster, but we don't have any good testing result numbers for that yet, but it's very promising. So it also, OpenVPN 2.4 supports control channel encryption, or TLS encryption, as an optional key usage type. So before you'd have a TLS key and that would offer you authentication for the packets on your control channel. Well, now you can actually flip that over so it actually encrypts that as well. So that protects the contents of the control channel and it provides privacy that way. And it also protects the certificate exchange, everything like that. It also provides protocol obfuscation, which means it's going to hide what that traffic is. It's going to make it more difficult for somebody in between to find out, hey, that's OpenVPN, I need to block that. So you have a good chance of getting past filters that might recognize OpenVPN or SSL traffic, if you are in a site or location that tends to filter that stuff. Another big win is it now can do negotiable crypto parameters, or NCP, for the data channel ciphers. So before, like, you always had to make sure everyone was set for the same thing. Like, everyone's set for AES-256, or everyone's set for AES-128, or everybody's set for Blowfish, or whatever. Now you set a list of ciphers, and as long as the two parties have a cipher in common off their list, they'll use that, and you don't have to worry about an exact match. And they've coded it in such a way where it's very easy to work with, very well defined for backwards compatibility and forwards compatibility. So say you've got a 2.4 client connecting to a 2.3 server, or a 2.3 client connecting to a 2.4 server, even if only one side supports NCP, as long as the other side wants a single cipher that matches anything in the list, it's going to work out fine. So it's really handy, and it was really well done. And we've got controls for that in our GUI now. If you look over here, you can turn it on or off, and there's also a way you can build up a list of the ciphers you want to use. Like right here, I've got it set for AES-256 GCM and AES-128 GCM, but you can also go through the list here and pick any ciphers you want and add them. And they will try to use them in the order you've defined over here. So you click them to add them to the list, you click them to remove them from the list. It's very, very straightforward. There's also ECDH options for elliptic curve DH if you want to use that in place of DH parameters for the key exchange. You can set ECDH instead of using DH parameters here. And then you can also set the ECDH curve. Now, our GUI doesn't support making elliptic curve certificates yet, but if you make them elsewhere and import them, you can use it in combination with that. It helps out there too. Another new bit is they have a different compression syntax in OpenVPN 2.4. The old syntax, like comp-LZO, has been deprecated, but they haven't removed it yet. But they're apparently wanting to get that out pretty soon. So they've also added LZ4 compression, which is a new compression style. It's got faster decompression, but it doesn't decompress as much. So you're still the compression speed's about the same. So you may end up transferring a little more data, but the decompression speed is going to be much faster. So less CPU overhead, higher potential throughput, if that was your blocker. And the compression setting also can now be pushed from the server to clients. And if you look here in the compression, you can see the new options up here are written out, and there's also the legacy options are still there for the time being because they're still there in OpenVPN. So there's several different options you can use, though, as long as both sides match or you can push it, you don't have to worry about it too much. There's new binding options for the interface that you can bind to IPv4 and IPv6 in a single instance. So when you do this over here, in your protocol choice, you now have, UDP on IPv4 only, IPv6 only, TCP on IPv4 only, and IPv6 only. And then you have UDP and IPv4 and IPv6 on all interfaces with multi-home. When it uses that bind to both, it has to bind to all interfaces. So no matter what you've chosen for the interface, it's going to bind to all if you choose that. And the multi-home keyword checks the original destination address. Like if your client contacted one address, it will recognize where it sent that packet and reply from the same address. That doesn't happen by default on UDP on pretty much any operating system. It will always go back like out your default route or whatever it thinks the best path to reach that client is. So that's a good win for multi-WAN. You're going to want it to reply back the way it came in, and then that way it'll handle that properly. Another change in that binding is that host names, if you have a host name in on a client for a peer address or a remote statement, whatever, it will try all of the entries that came back in a DNS record. So if you came back with multiple records like a quad A and an A, it will try all of those in turn for your remote statement. So that's a good way you could buy some extra redundancy without multiple remote statements just by adding more replies to your more entries to your DNS record. The server can be set to push IPv6 DNS, uses the same fields as IPv4. You can just put an IPv6 DNS server in there now. We have IPv6 support in the status and output widget finally. So if you go over here to status OpenVPN, if it's got IPv6, it'll show you like in the virtual address here. Same back here with the widget. Shows you IPv6 in the widget, which is about time. They finally added that in OpenVPN 2.4 and it works nicely. There was a ton IPv6 option they used to have. It's deprecated now. IPv6 is always enabled. So if you really don't want IPv6, you can not fill in a tunnel network, but it's still going to try to think that the interface is IPv6 enabled. There's not a good way to just do IPv4 anymore. Also, they changed the CRL verification. It's all handled by OpenSSL now. It used to be OpenVPN verified it internally, so you might want to verify your CRL behavior. Try 2.4 in the lab, make sure you can do things. When I've been trying it out, I'm still not exactly sure what the differences are. I haven't had any trouble or differences with it. Adding things worked fine. There was one case where I tried to remove a CRL, and I had to jump through some hoops to get it to realize that it was gone, but it didn't happen every time I tried it. So that still needs some better testing and definition for what that difference is. But just something to be aware of. Your CRL behavior might change a little bit. We improved the help text on client-specific overrides, so it's a little bit more thorough and complete. Also, we fixed some issues with OpenVPN on dynamic and tunneling interfaces. So if you're trying to run OpenVPN on, say, an IPv6 Hurricane Electric tunnel interface, or if you were trying to change settings on a WAN that was set for DHCP and it's down, you can save that and it's not going to be a problem now. Now, there are some improvements that we've put in or have come through that are also applied to 2.3 2.3.3 as well as 2.4. For instance, we've got, if you used radius authentication for a remote access type VPN, that's going to send a proper like NAS port type, NAS port, NAS identifier to your radius server when it sends the authentication request through, or is it accounting? Either way. We have a new option in compression that says no preference and adaptive compression disabled. What that does is it helps you cope with clients that were compiled without compression. Some time ago, OpenVPN changed the default so that compression is enabled by default. So it was not simple to just say you didn't want that, because if you put comp LZO no, it would still think that compression was enabled, just turned off. You know, it was in the client but turned off. A client without LZO compiled in at all would just barf on that. So this new setting, you know, no preference and adaptive compression disabled, tries to fill that niche where you're trying to deal with some really obscure client that just doesn't have LZO at all. It's very rare, but we've run into a couple in support where we've had to work around it before. So we added the option because they're out there. You'll hit them every once in a while. It's usually things like, you know, weird esoteric WRT builds for really small hardware that they're trying to save every byte of memory and space on. We also added an option to help block non-VPN DNS on Windows 10 to prevent DNS leaks, because by default, Windows 10, when it sends out a DNS query, it's going to query all servers at once, sort of like DNS mask does. And you probably don't want that, because if you're on the VPN, you want them to get the reply from your server, your VPN DNS server. And B, when you're connected to the VPN and it does that DNS query out, it actually leak that to a public server potentially, and you may not want anybody to know what you're trying to query over the VPN. So in both ways, it's good to have that to block that. And that setting is specific to the OpenVPN client on Windows 10, but there's a checkbox on the server to push that option to clients. But we try to set it in a way that is nice to other clients so that, you know, they won't reject the option outright. So that should be pretty safe to use if you need it. We've also improved the handling of chained and intermediate certificate chains, or like CA entries. So before, if you had like a root CA and an intermediate and then your server certificates and client certificates, you might have had to have made a weird entry that had both of them pasted into one entry, and those are not going to work anymore. You actually have to change them into a proper, you know, you've got your root CA entry imported, you've got your intermediate CA entry imported, and then, you know, your certificates. It will find the chain automatically, and that works, you know, in the base system and in the export package. It'll find those chains properly now. Let's see what else here. Oh, the OpenVPN widget now updates dynamically, so it updates with Ajax, so that's good. You've got our server list, which shows a little bit more information about each server. So it tries to show you some of the crypto parameters, and, you know, it's got a little bit more information. You compare that over to the client list and see that it doesn't have that extra column. But also shows you like your ton versus tap mode and just a little bit more information. We may have to beef that up a little bit yet, and we need to get the client tab, you know, in parity with that as well. Let's see here. Also, if you had an authentication server, like an LDAP or Radius server that had a special character, especially like an ampersand in the name, some people were having issues with those they would work for other things like the GUI, but they wouldn't work for OpenVPN. We've addressed that. So if you had an issue with that in the past, you can either, you know, fix your name or go back to how you wanted it originally, or you can use it for OpenVPN now. On client-specific overrides, we added an IPv6 tunnel network field that wasn't there before, but it should have been, but now it's there. And also, the biggest win of all here is that the OpenVPN 2.4 Windows client no longer needs administrator privileges to run. How it works now is the OpenVPN 2.4 client has a brand new service that they rewrote that manages things in the background, and the GUI front end just talks to the service. So the service, you need admin privileges to install it, but once you've got it installed, your user does not need to have admin privileges to run it. It can just run, and it interacts with the service, connects and disconnects, and it works just fine, just like it always has. End users may not even notice a difference, other than that they don't have to click through the UAC dialog when they run it, or, you know, whatever else you had to set up to get around that. So And that is in the export package for the Windows clients in the export package, and that's available to everybody right now. It's on 2.4, 2.3.3, and 2.3.2.1. So if you make sure you get your export package updated, then you can start exporting 2.4 clients. And those, as I mentioned, they're really good about backward and forward compatibility. So you can use the 2.4 client with a 2.3 server, no problems there at all. There's a warning in the export package about running a 2.3 client against a 2.4 server if you've used 2.4 specific options, but it's just a warning. It's not an error at all. It's just letting you know that, if you want 2.4 stuff, you got to use a 2.4 client. Okay, moving on to things that are a little bit more specific to OpenVPN. In general, I mean. You have two possible device modes for OpenVPN. You got TUN and you got TAP. TUN device works at OSI layer 3. It does IPv4 and IPv6. So your lowest possible information you're going to be able to get of that is IP address to IP address. So it's just IP traffic, back and forth. That's it. It's the TUN device is the most common you'll see. It's what we default to. It's what most things default to. And it's compatible across multiple platforms. For example, like iOS and Android clients, they won't have any way to do TAP. They'll only do TUN, for example. So TUN is probably what you want in almost every case. It has less per packet overhead than TAP, but it is treated as a point-to-point interface by the operating system. Sometimes it's good, sometimes it's not so good. I'll mention, there's a caveat to that in a bit, I'll mention when we get to OSPF. The TAP device, it actually works at OSI layer 2, carries 802.3 information, so you can get MAC address to MAC address traffic. So it could be IP traffic or other stuff as long as it's layer 2 or above. Now that's good for some things because you can carry more detailed information. You can bridge it, like to your LAN. You can carry broadcast and multicast. And you can talk ARP or DHCP or whatever you want to across that because it works sort of like a bridging or in general or a switch. You can expand that across. Now, there is more per packet overhead because of the need to carry that extra L2 info, so your total potential throughput is going to be a bit lower with TAP. And we generally discourage bridging because you're going to have some trouble, especially if you're trying to do site-to-site with bridging, because that's just a mess of trying to make sure that they have independently operating things like DHCP and no IP conflicts, and make sure you're not creating any kind of a giant mess of multicast and broadcast traffic pinging back and forth. So you need to be careful there. We don't recommend doing that for site-to-sites. For remote access VPNs, you might want to. I'll talk a little bit more when I get to the TAP bridging about why you might want to do that. It's a little bit more common to see TAP bridge remote access than it would be a site-to-site, but still, there's still relatively few of those in the bigger picture. So looking at the OpenVPN tunnel networks, there's several different ways you can operate in tunnel network mode. So you've got your shared key, which is just your standard basic shared key. There's SSL TLS/30 tunnel network, which works similar to shared key. We've got SSL TLS in TUN mode, which uses like a /24 or similar, just a bigger subnet. You can use topology net 30 in that mode. Operates one way. And then you have SSL TLS in TUN with topology subnet or TAP mode, and those operate the same way. And that's going to be the one we're primarily going to focus on because that's going to be your default or most common way you're going to see this. So for shared key tunnel networks, the shared key is always going to use 2 IP addresses regardless of your specified subnet size. So if you say 10.0.8.0/30, it's going to use .1 and .2. .1 for the server, .2 for the client. It doesn't matter if you do 10.0.8.0/24, it's still going to use .1 for the server, .2 for the client in shared key mode. So it creates a point-to-point interface in the operating system that actually says, I'm .1 going to .2, for example, and vice versa on the client side. So both the client and server use that interface address to reach each other. So the server knows .1 goes to .2, client knows .2, it's .2, and it knows it goes to .1, and they talk to each other. The operating system sees that on both sides. One of the big downsides to shared key is you can only have one client per server. You can't have multiple clients in a single server. and you can't push settings to connecting clients, so you have to completely configure everything on both sides. So an SSL TLS with a /30 tunnel network behaves the same as shared key, except you can use certificate authentication instead of your shared key authentication, but it has all of the same limitations. You can't push settings, you can only do one client, and the point-to-point instead of everything. It all operates the same. So your SSL TLS and ton net 30 mode, this was our default in previous versions. I think back in I think it was before 2.2 we switched 2.1 and before. So it was the old default behavior. It's not the default now, but it's still pretty common to see. You can handle multiple clients and you can push settings to clients, so it's not too bad there. But when you set up SSL TLS in this mode with a large subnet, every client is assigned a /30 slice of the entire tunnel network. So it carves that up, but you waste a lot of addresses. So every client gets 4 IP addresses. There's a null route, the server IP address, the client IP address, and the broadcast. So every client consumes 4 addresses. Even though only 2 are used, you still have to deal with the network limitations of using a /30. So that means in a /24, you're only going to get 63 clients. That first /30 is taken by the server, and then you have all the rest of those available. So you can do client-specific overrides for these, but you have to set the static address with /30 notation, and you have to get the address right in there and know what you're doing. So like you'd have to use like 10.08.224/30, and it would use 225 for the server, 226 for the client, and so on like that. So you have to make sure you calculate what you're actually setting the client for in addition to the /30. So there's some confusion there too. And even though you set IPv4 this way, IPv6 is always going to use a subnet topology, so you can't use net 30 with IPv6 in a consistent way. And these extra /30 subnets, they're handled inside of OpenVPN. They're not exposed to your operating system. So on the server side of things, you're never going to see them. But the clients will think they're there, and OpenVPN, internally knows what to do with what. Because they are isolated in that way at the operating system level, you're not going to be able to do like broadcast or multicast working between clients or servers. And if you want the clients to reach each other, you need to push a route for the tunnel network itself. Like in the local networks, you have to put the tunnel network again, and you also need to activate the client-to-client option. We don't have a GUI option yet on SSL TLS peer-to-peer, but in remote access SSL TLS, there's a allow clients to communicate with each other option that shows up. But when I was doing some checks for this, I realized that wasn't there. So we'll get that put in on 2.4. Just it's not there now. All right, and lastly, the most important one is SSL TLS and subnet style. So you've got your ton with topology subnet, and that is our current default. SSL TLS in tap mode and ton with topology, they work the same way. You can have multiple clients, you can push your settings to clients, but it groups everybody into one large actual subnet rather than sets of separate networks. So everybody's on the same thing. You've got a proper subnet mask. It looks like you'd expect an interface to look. So the server gets .1 in the subnet, or the first address in the subnet, and then clients will get just one address added up from there. So like your first client's going to be .2, the next one's .3, then .4, then .5, and so it makes sense the way it uses it. It works more like a traditional local network. Your client-specific overrides, you can set a static address using the same bit mask as the server. So if you want a client to have .99, you can do that. You can do so you do like 10.08.99/24. You just need to make sure you use the same bit mask as the server. You can do broadcast, multicast between clients and server. However, there is some weirdness with multicast on subnet topology because the operating system still sees a point-to-point interface. It'll fail, like especially OSPF will, and I'll tell you why in a minute. So if you need broadcast or multicast, again, you can use tap. It can have, and so you can basically just have to switch from ton to tap. I mean, otherwise they operate the same way. And the subnet topology does have some quirks with older clients, especially like really old Windows clients. But as long as you're on a current version of the OpenVPN client, like 2.4, or even the latest 2.3 on like Windows XP, because the 2.4 client requires Windows Vista or later. you'll be fine with subnet topology. It's been fixed and okay for years, but you might find some embedded OpenVPN clients that that need updating that are out there from eons ago. Okay, so there's a VPN routing, several different ways you can accomplish VPN routing with OpenVPN. You can do static routing, which is what most people do. Lets OpenVPN handle the routes. You can do policy routing, where you handle it in firewall rules, or you can do dynamic routing, which is handled by a routing daemon like OSPF. So for static routing, it's the most common kind. Everyone's using it, or pretty much everybody's using it. Your routes are present in the firewall operating system routing table. The routes are managed by individual OpenVPN instances. So it's managed by OpenVPN. So you never want to manually add static routes under system routing for those. If you try to add a static route under system routing, it's not going to work right. Like it might work the very first time you hit save and apply, but anytime it disconnects or restarts or whatever, it's not going to get applied right. So don't use system routing. Let OpenVPN handle everything. And how you do that is you add these routes in using the remote networks for the remote IPv4 network or remote IPv6 networks. Any network you put in there, and you can do a comma-separated list of however many you need. And it will add routes for those to the operating system routing table. And that tells the operating system, says, send traffic for those networks to this particular OpenVPN instance, like OpenVPN server 1, server 2, whatever. So if you've got SSL TLS in ton mode for multiple sites, or I guess it could be in tap mode as well for multiple sites, you need to do an iRoute, which is an overrides, which I'll talk about a little bit later. And that way OpenVPN knows which networks are reachable through which particular specific client connections. Otherwise, it wouldn't know what to send where. It just knows, okay, the operating system knows to send it to OpenVPN, but OpenVPN has no idea what to send where. So that the iRoutes and things in your client in your overrides let OpenVPN determine that. And if you are using SSL TLS with a multi-site network, you can put, or even with remote access, you can push those routes out on the local network boxes. So that's good. Okay, next up is policy routing. So in order to do policy routing, you have to assign your OpenVPN interfaces, which I'll get to in a minute. And when you assign them, you get a dynamic gateway. And the route, when you do it this way, there's no routes in the routing table. Your routing is managed entirely in PF by setting up policy routes, matching it firewall rules and using your VPN gateways. So you could use a gateway group and balance across multiple VPNs. You could do failover from one VPN to another. You could even failover between a VPN and a WAN if it's internet style traffic. And the inbound and return traffic would be handled by reply to, which I'll cover that in a little bit more detail when I get to setting it up in a bit. So your last choice here in general is VPN for dynamic routing. So in this case, the routes are present in the routing table, but they are not configured in OpenVPN. Your routes are managed by a package like OSPF, where you could do BGP. Those are the only two options we have at the moment. The routing daemon can change routes quickly and depending on your configuration and conditions. So it could react pretty quick to changes, but it's all handled, automatically negotiated between the nodes. They tell each other what they have, so you don't have to worry about configuring it in all one central location. Okay, let's look at assigning OpenVPN interfaces. So why would you want to do it? Well, it enables additional configuration choices for handling traffic to and from the VPN. When you assign that VPN interface, it automatically gets you a gateway for IPv4 and IPv6. Like for example, let me look over here and show you. I've got this VPN WAN interface assigned, and it has, like under gateways here, you can see I've got my VPN WAN, I've got an IPv4 gateway, and I've got an IPv6 gateway. So it automatically gets those gateways. You don't have to do anything special to set those up. It also adds a firewall rule tab for rules specific to that VPN. So if I go to firewall and rules, see I've got my VPN WAN tab here. I don't have anything, since it's a WAN, I didn't have anything allowed back in there. And it also allows that interface to be selected for use elsewhere in the GUI, like in rules, like in NAT rules and things like that. So you got outbound NAT, port forwards and others. You can set those to be specific to that VPN instance instead of for all of OpenVPN, which can be handy in certain conditions. And because it gives you those gateways and other things, it lets you do policy routing. So that happens from the gateway that gets added. So with policy routing, you can do some pretty good little handling of your traffic. So you could send like one specific client over the VPN but not others, or you could send everybody over the VPN except one person. You could match all HTTP traffic and send that over the VPN but nothing else. So anything you can match in a firewall rule, you just write up a rule, match it, set a gateway, make sure it matches first, and it'll follow that gateway choice. And you can also use those gateways in gateway groups. So like I said, you can fail over between multiple VPNs, VPN and WAN, however you want to do that. You can also do load balancing to where you can send traffic across multiple VPN connections. When traffic enters and matches a rule that matches just one of these tab rules for your assigned interfaces, that traffic also gets replied to. So if it comes in across that VPN, it's going to exit back out that VPN. So that's good as well. And again, just a reminder, even though it makes a gateway, do not use it for static routes. So the firewall tab assignment lets you get fine-grained control of the traffic, you get the user reply to. Reply to handles all your return routing, so traffic comes in an interface, it exits back out. So with that reply to, you can do public subnets if you need to. You can use port forwards or one-to-one NAT across a VPN when the traffic source is any. So say you've got two sites. One site has a public subnet, and you want to route traffic, like either a whole subnet worth of traffic, or you want to say do a NAT rule on that site and have it reach a server that's at a different remote site. And that's a good way to handle it here, because it will match that NAT rule, the target sends it across the VPN, enters that VPN, hits that reply to rule, and then that far end VPN is going to know, when that server eventually replies, it's going to go back out the VPN it came in. So in order for that to work, you need to pay attention to the way the rules match. And how they match is you have your OpenVPN tab, which is always going to be there, but you don't want this traffic to match those rules. So your traffic has to only match rules on the assigned interface tab and no other tabs. Like you can't have it match a floating rule, or you can't have it match an OpenVPN tab rule. So you don't want to block it on the OpenVPN tab rules, because that would actually block the traffic. You actually have to craft your OpenVPN tab rules so it doesn't match at all. Alternately, you could assign all of your OpenVPN instances and then remove all of your OpenVPN tab rules. But it's really up to you however you want to do that. Just keep in mind the processing order, which is floating rules first, then groups, which includes the VPN tab, and then your interface tab rules. So you see here, I've still got OpenVPN tab and I've got an allow all. So it doesn't really matter what I do on any of these other assigned VPN interfaces. Anything coming in that VPN is going to be allowed. Which in this specific case with a VPN provider, wow, that's pretty bad. You don't want that. So yeah, you want to make sure that you craft those properly. And what you would do on the OpenVPN tab rules, for example, is you would change your sources so that your sources only match the possible sources for other VPNs, which may be a lot of rules depending on how many VPNs you've got, but it's necessary. You got to get those rules matching right. So actually performing the assignment is pretty simple. You just go up to interfaces and assignments, or assign on 233 or before, and you'll see it in the OpenVPN. You'll see your OpenVPN here in your available network ports list, and it shows your OpenVPN description. So if you filled that in, it should be pretty easy to pick out which one is which. So you find it in the list, click plus to add, and that will disrupt the VPN. So do not do this from that VPN. Come in the WAN, come in the LAN, whatever. Once you do that, it will add your interface here in the list. It'll be another, it'll just add another opt interface. So it'll be like, opt 4, opt 5, whatever. And so you go up here to your interface and, check enable, give it a good description name. Like I called mine VPN WAN. It could be, like VPN A, VPN B, whatever. Make sure you leave the IP configuration type set to none, because OpenVPN manages that itself. And then you don't have to set anything else on here. Just check enable, give it a name, and click save and apply. Now, when the moment you assign it, it's going to disrupt the VPN, and then edit and saving here would disrupt it again. So once you've done the assignment, go over to OpenVPN and find your server or client instance, edit that, and then save it, and that will restart it, have it reconfigure the interface and do what it needs to do to get back online. And that's something we're kind of looking at cleaning up in 2.4, making that a little bit smoother. All right. So now that you know how to assign interfaces, we can talk about some more of these multi-WAN tactics a little bit more. So you can, some multi-WAN tactics here, you can do multiple remote statements, which is built into OpenVPN. You can do gateway group failover, which you assign the gateway group as the interface of a VPN. You can do policy routing, or you can do dynamic routing with OSPF. Now, if you're doing multiple remote statements, it's useful if the server has multiple WANs. It can work if there's with static key or SSL TLS. It doesn't really matter. It's features built into OpenVPN, so there's nothing extra or fancy you have to do to get it going. And all you do is add additional remote statements into the advanced options. So you just put like remote, and then a space, and then the IP address of the next connection to try, and then a space, and then the port number, and then a space. And you can put UDP or just leave that off if it'll assume the protocol based off what's selected for the instance already. So you could have like remote, and then the address of WAN 2, and then the port, and then a semicolon, and then a remote, and the address of WAN 3, and then so on and so forth. However you want to do that. The downside of this is your VPN is going to be down for at least 60 seconds before the switch, because OpenVPN sends keep alives, and after 60 seconds, it will consider the connection dead. And at that point, it will try to connect to the next remote statement. So it's going to take a while for it to notice that the VPN's down, and then it tries to get to the next one. But anything that disrupts your VPN is going to send it onto the next remote. It doesn't necessarily mean there's a failure on the server or client side. There could just be something in between you that routing had just a blip for a minute or so, and it's going to try the next one, and it'll go on and on trying the next one until it hits one that it will connect to. This does not fail back automatically. It will just keep using the same server until it gets disrupted. So like if your WAN 1 happened to be down on the server side and the client latched on to WAN 2, when your WAN 1 comes back up, that client's just going to sit on WAN 2 indefinitely until something bumps it off. So if the client side is also multi-WAN, you can do a static route on the client side so that one address goes out WAN 1, another address goes out WAN 2, or you could try like a gateway group interface for the client side. But there's some other options there, but we'll talk about some of the things that are better for that scenario. So mostly you'd want to use this if the server's got multiple WANs, you don't care about the failover time, you don't really care which server they talk to, so you don't really have a preference for WAN 1 or WAN 2. You don't need to worry about failback, or you could do like disaster recovery with this without anything like BGP, so you could fail over to a completely different site. So you don't have to, without using any kind of routing protocols. All right, so the next tactic we got is group failover, gateway group failover. So in this case, you make your gateway group with your WANs, your failover group. So like WAN 1 on tier 1, WAN 2 on tier 2, and then you use that as the interface. You can use this on clients and servers, but we don't recommend using it on servers. The reason being it's active only on one WAN at a time, which doesn't matter for a client. It's only ever using one anyway, but on a server, your client could be unable to reach WAN 1 for no reason that the server could discern. So it may not know that it should be able to switch over to WAN 2 for the client to get there. So there are several scenarios this doesn't cover where your client and server couldn't reach each other. Sorry. So, and this also can work with static key or SSL TLS. And it can be used with multi-WAN servers, but we don't recommend it, like I just mentioned, because it can be slow and troublesome. The better option for the server is to use one instance, you bind it to localhost, and then you put port forwards on each WAN that send that traffic in to your single instance. That way it's reachable by both WANs at all times. That way your clients can reach either WAN, no matter what's happened in between. Another option that's similar to that is on 2.4 if you use bind to all interfaces with that multi-home option I mentioned. That should also get you a similar good behavior, though I still kind of prefer to use localhost with the port forwards because that's what I'm used to. But I'll talk a little bit more about that in a bit too. Your failback time here, it depends on your gateway monitoring settings or your failover time. Could be anywhere from 10 to 60 more seconds. It really depends on how you've got your gateway failure set to trigger. So it could take it a while to realize that it has to fail over. It will fail back. It'll cut your VPN off and fail it back to your preferred gateway when it comes back up, which can be good. So especially if you're using if you've got like a metered bandwidth on like a 3G interface as your backup, you might want to cut that off and move it back over to your primary WAN as soon as possible. So if you do want to use this on the server, you have to also set up like dynamic DNS so that the client knows what to connect to, or you could do multiple remote statements on the client. But again, it's kind of slow to do either way. Either one of those scenarios is kind of slow, which is one of the main reasons we don't recommend doing that. So why would you want to use this one? Well, you generally wouldn't, but if you don't care about failover time, you've got state killing on gateway failure enabled to make sure it gets kicked. If you've got if you absolutely require failback, then it's going to be okay. And sometimes if the other options are too complicated, or you don't want to try and set them up, you can go for this as well. But generally speaking, you're not going to want this option unless you really need failback and you really can't use one of the others. All right, so next up, policy routing is useful for multi-WAN clients and servers, depending on your scenario. You can only do this with point-to-point VPN. So we're talking static key or SSL TLS with /30s to where it's a point-to-point A to B, one client per server. You can do connection-based load balancing or failover, but not aggregation using gateway groups. So you can do load balancing of connections, like connection A goes here, connection B goes there, but it doesn't do aggregation like packets go on different VPNs of the same connection. So just like regular multi-WAN. And it can spread that across. And I've seen a customer had this going with I think it was 8 different low bandwidth WANs, and they were pretty happy with it. So it can work out pretty well. So what you have is you have a tunnel up on every WAN at all times. So one tunnel, one server, and one client per WAN on both ends. So you've got one server per WAN on one side, and you got one client per WAN on the other. Even if your one side only has one WAN and the other one has a bunch. Like say you've got one really fast WAN and several slow WANs, it's still good to have one on each WAN going that way. When you set these up, you do not add routes into OpenVPN, so leave your local and remote networks blank. Well, the local networks wouldn't work because you're on static key anyway, but leave your remote networks blank. If your firewall has to reach over the VPN itself, you can add routes to one instance, but you can't add them to multiple because the routes would conflict. So just add the route to one instance, and at least then you can reach across the VPN unless that one happens to be down. So when you're setting these up, you just have to put in like the keys, your encryption and auth settings, compression settings, and unique tunnel networks. You don't have to set up anything else extra fancy. Don't have to worry about routes, anything like that. You have to assign the VPN interfaces on the client and server, so assign every single one. Just like I said, you got to enable them, you got to give them a name, make sure the IP types are set to none. Save and restart the VPNs after you do that. Your failover time is going to depend on your gateway settings. If you're load balancing, you shouldn't notice too much. It'll just take the failed WANs out of the load balancing group. So it should be pretty straightforward there. But it can be kind of slow to switch, as before, with relying on a gateway group. When the first WAN recovers, new connections will start using it again, but existing connections won't be cut off to move it back. So it'll fail over and it will sort of fail back, but not fully, in a complete way. And again, when you're setting these rules up, OpenVPN tab rules cannot match the traffic. It must not match because it has to use reply to make sure that it sends the replies back to the right VPNs. If you mess up the rules and it doesn't match right, you're going to find that either the traffic won't go back at all because it has no idea where to go, or if you put a route on one VPN and none of the others, it's going to always use that one VPN to send the traffic back, which is really inefficient. So yeah, you got to make sure you get the rules right. Place the rules on the assigned interface tab and make sure you've got your OpenVPN tab rules, either they're gone or they don't match. And then after that, you add your rules on your LAN, match the traffic, add the gateway group, and it's just going to take off and fly. It's pretty straightforward from there. So you'd want to use this one if you fail over time. Again, it's not too critical. because you're relying on gateway monitoring. It could be a minute or so before it realizes it's down. Kind of a small number of sites. I say 2 to 6, but it's really at your discretion. There's just a lot of setup involved. You can have a lot of server instances. You're going to have a lot of client instances, a lot of keys, things you got to manage. There's just a lot of work. So I don't like to use this one for a lot of sites, but it can't. Depends on. It's all up to you. If you're okay with that, you can keep going. If you want load balancing for additional bandwidth on your VPN, this is a great option. And it's also, if you want to do partial failback, that's okay too. So your last option here is your dynamic routing using like Quagga. So it's a routing protocol daemon. You have to run that routing protocol daemon on all nodes. So each node keeps track of what networks it knows about, and then they'll get together and they'll talk and they'll exchange neighbor information and say, okay, I've got these networks, you've got these, and then they determine who gets routed where, based on that. So this is useful for multi-WAN servers and clients. It does require point-to-point VPNs like your shared key or your /30 or tap mode SSL TLS. Won't work in ton mode even with topology subnet. You've got one instance per WAN, again, just like the last option. Shared key /30 needs one server per WAN and per client. Very low time to change compared to the others. Routing protocol will know something's up and it will swap things out pretty quick, just a few seconds in some cases, depending on your hello timers and things. It will fail back automatically and completely. And when it does fail one way and the other, you shouldn't have hardly any loss of connectivity or connection interruption. So it's pretty good that way. Does require more complicated setup because you have to set up the routing protocols. Your tunnels are going to be up at all times in all your WANs, and this is a good option if your failover time is critical, and if the added burden of setting the routing protocol up isn't overly cumbersome. So it's a pretty good option, but it's kind of complicated. I'll talk a little bit more about setting up OSPF here. You can use it for failover, or you can use it to link up multiple sites without having to maintain your individual routing. It can make some things a little bit more complicated, but other things it makes easier. So it requires multicast, so you need the static key or /30 SSL TLS, which is the easiest thing to work with. But you can do a multi-site setup where you have SSL TLS in tap mode. It doesn't work with topology subnet because Quagga sees, hey, it's a point-to-point interface, and it says, I can't have more than one neighbor on a point-to-point interface, and it just gives up. It says, no, you can't do that. So you have to use tap mode, but again, like I mentioned earlier, the only difference between tap and ton mode with topology subnet is just going to be picking tap versus ton of the dropdown. Logically, the rest of the settings are all the same, so you don't have to worry about it. Just switch over to tap mode and you're good. On the server side, you need 2 unique server instances, per client site for shared key, or each one for a separate WAN. You might be able, I haven't tried it with the port forward method, but you could try that out so you just have one big server on the server side. Not sure how well that might work out in the long run, but it may work okay. So if you're doing peer-to-peer SSL TLS tap, you do need to add the client-to-client option in the advanced options, like I mentioned before. If you don't have that in there, through the main site, the remote nodes will see the routes they need to use. They'll be pointing at the other remote nodes, but they can't get there without the client-to-client option. So you need to, if you have that client-to-client option, they can each form a neighboring with each other, and they'll know where to send the traffic, and they'll actually be able to reach it. So you need that option set. Let's see, you need to use distinct non-overlapping tunnel networks. So everything has to have a tunnel network on it, like 10.0.80/30 on one WAN's instances and 10.0.90/30 on the other, and then maybe for each client you count up to like the next one, like 10.0.84, 10.0.94, and so on and so on. That's all up to you. As long as they're unique and they don't overlap, you're fine. But again, do not put routes in the remote network boxes. OSPF will handle all the routes. On the client side, you set up 2 clients, one for each server, each on a separate WAN. So like this instance, I've got A1 to B1, so WAN 1 on the client, WAN 1 on the server, WAN 2 on the client, WAN 2 on the server. That will cover most of your scenarios, but it's not going to cover everything. It's kind of overkill, but if you want complete redundancy, you need to cover all your scenarios: A1 B1, A1 B2, A2 B1, A2 B2, or you have A1 B1, A2 B2, and you just have like multiple remote statements, so they might try the other another WAN automatically. So how exactly you get to that point, it's up to you. I would start with just the simple A1, B1, A2, B2 scenario and work up from there. So you need to make sure your OpenVPN tab firewall rules pass OSPF traffic. So you allow each side to ping the remote ins tunnel network, and you can pass OSPF. It's multicast traffic, so you can't really filter on the destination unless you do all the OSPF possible multicast groups and everything. So it's easier to say, match OSPF and leave the destination any. This stuff's not going to leave your segment anyway. It's not routable traffic, so it's not a whole lot to worry about for destination. Check that your VPNs come online. You can ping in both directions, so you don't have to assign them for this. So you can really just do like a simple ping test, or you can just look at status OpenVPN. See right here, just make sure you're connected on both sides. Status OpenVPN. See, it shows me my instances are up. Here's the client side is connected to the server side. Everything looks kosher. So you're not going to do a LAN-to-LAN test yet because first you have to set up your routing protocol. So first thing you need to do is go to System and then Package, your Package Manager, go to the available packages, find Quagga, install it just like installing any other package. So you could assign the interfaces if you want, but you don't have to. So if I go back here just under Services and Quagga OSPFD on both of them, the first thing you need to do is set up your interfaces. So you do the interfaces tab first, you don't do global settings first. So in each of these, just go to interfaces. So you add your VPN interfaces in. So pick it from the list. It'll show you the friendly name here on this screen. It doesn't on the last screen. Give it a metric. Like I put WAN 1 at metric 10. I give WAN 2 a metric 20. You could do whatever metrics you want there, as long as the one you want to prefer has a lower metric than the one you want to use later. For your VPN interfaces, I would check accept filter here so it doesn't try to send a route for the VPN tunnel network itself across. Otherwise, you might have some trouble where it learns its own route over the OSPF and then can't restart itself right. So you add those in. You add one VPN, add the other VPN. So I've got both of my VPNs in. And then add the LAN interface as passive. That way, it's not going to actually send out OSPF traffic on LAN, but it's going to say, hey, I need that network to be distributed by OSPF. So like you'd have a LAN, DMZ, whatever, those would be passive interfaces. And then do the same on the other side. You got your VPNs, you got your LAN. And then after you've done the interfaces, you can come over here and do your global settings. In your global settings, you just create a random master password. Doesn't matter what it is. This is just used internally to access the management interface. I like to turn on the logging, at least initially, to make sure, until things are up and running right. But even after it's up and running, it's good to have those so you can tell why something failed if it failed. It just gets written to the routing tab under the system logs. Your router ID, I just put in the LAN IP address of the firewall. Area ID, I just use all zeros, 0.0.0.0. If you have multiple areas, where you're connected to different distinct routing groups, you can use, obviously, a separate area, if you need to specify a particular one, or you can put interfaces in different areas, but that's beyond the scope of what we're doing today. And you don't have to set anything else at all on the rest of this. You could mess around with the other options depending on what you want to distribute, like redistribute kernel would redistribute routes that are in your firewall routing table, which are, static routes on pfSense or routes you've learned from other things like other VPNs. And there's other things you can tweak, like your hold time and delay, and where you can tweak the timers so it's either more or less prone to detect failures. And you can also add in additional networks you want to route manually, or you can also optionally disable routes, like if you've got a particular route that you never want to go or send to your OSPF things, you could disable redistribution, or if there's something local you don't want to take in, you can disable acceptance. And you can add in multiple networks there. It's pretty straightforward. So when you're all done with that, you can hit save, and it will start up. And then do the same on your other node. Go through, you can see general settings did the same thing, different router ID, same area, and nothing else. Just save. Now at this point, you can check on the status. It might take it a few moments to find its partner or to find its neighbors, but you can see here it shows two entries for the same neighbor by two different addresses on two different VPNs. So everything is good there. It's got the OSPF database, you got router database, a lot of information here. Mostly you're just worried about seeing your neighbors showing a full relationship. And you want to scroll down here and look at your Quagga zebra routes. In the zebra routes, you're primarily interested in the interfaces that have the O. Those are the routes you've learned and selected from OSPF. So it's got an O, it's got angle bracket there. It's one you've got from OSPF and it's selected and active. The star means it's in your routing table. So as you can see here, this side is the 10.5 side, and it's actually got, see my LAN interface is 10.5 connected to my VMX1. But if I look here, OSPF is right now coming through OpenVPN server 5. If I come over here, look at my status, this is the other end, look at the zebra routes. It has an OSPF route for 10.5 and the 10.7 network is directly connected. So it's found that route over OSPF, and OSPF is managing it. And if I kill one of the WANs, it'll flip to the other one. So pretty straightforward, but once you've done one or two, you can knock the rest of them out. It's pretty easy. So switching back to talking about when you've got a single server that has multiple WANs, like if you just want to use a single server instance, this is pretty common for remote access VPNs, and it can be used for like the multiple remote statement type method as well. So you've got two different WANs, and on each WAN you have a port forward for port 1194 down to localhost. And how that works, it's gonna, it just works like any other port forward. The client tries to connect to port 1194 on WAN 1, it's going to forward that to localhost port 1194. And so in your OpenVPN server, you bind that to port 1194 on localhost. Then the rest of it is just, your typical style thing. In this example here is a server site to site, like a point or a peer-to-peer type tunnel. So you've got a tunnel network of 10.0.80/24 and a remote network of 192.168.2.0/24. And so this is like a shared key type example, even though it's got a /24. And so the client set the same way, but it's got the server address for WAN 1 in the server, and then down below in the advanced options it has remote and the WAN 2 address with 1194. So when you're doing that, when you're setting it up, your first option, like I said, is to use localhost as the server interface. You port forward from WAN to localhost. Your other option is to try the multi-home on 2.4. And you can use that, any for the server interface, and then select IPv4 and IPv6. It'll add that multi-home keyword for the protocol. For the remote access VPNs, the client export package knows the port forward method automatically. There's the hostname resolution has two options for either using DNS or the interface addresses with multiple ports, or multiple ports on the same WAN or multiple WANs. It knows how to work all of that automatically. It's really nice. We have not coded anything up for the multi-home method yet for remote access VPN. So if you're wanting to try that out, you would have to manually account for that in in your client configuration until we get that accommodated. It's just not there yet. So for a site-to-site VPN, you can do it with static key or SSL TLS. It doesn't really matter, just as long as you use the second remote statement in the advanced options. And if your client has multiple WANs, you could do a static route. Like one WAN goes out WAN 1, the other server WAN goes out WAN 2. An alternate tactic there is, you can fall back on using dynamic DNS. If your dynamic DNS is set to multi-WAN, you could, it can fail over your clients from one WAN to the other, or you could do round-robin DNS if you don't care. But using DNS for that at all is going to be a little slow because records will live for a certain amount of time, and then also have to worry about propagation time and everything else, and how long things get held in DNS caches, and depending on your record setup, it could be a slow process, a couple of minutes. So if you have multiple servers and multiple WANs, that's when we talk about clients have multi-WAN, servers have multi-WAN, or you've got multiple servers, like you've got, shared key, one up on each side. Then it looks a little bit more like the graphic we see here. Second. So you've got your WAN 1 with server on port 1194 and one tunnel network, WAN 2, server on 1195 with a different tunnel network, and then you have corresponding clients on the server side. Each one is set to the individual server. So it's a one-to-one relationship, like the shared key or SSL TLS/30/30. So you'd want to use that for remote access or route with a routing protocol or policy routed style only. You can't use that for a traditional site-to-site because the routes conflict. So that's why you'd have to use the routing protocol or policy routing. So that assumes the server and the client have the same number of WANs. So you have one instance per WAN bound directly to each WAN, and they have to have different tunnel networks. So the other settings can all be the same. You can use the same CA, same certificate, same TLS key, same authentication settings, cipher, whatever. All that can be identical, just different tunnel network. And if the client only has one WAN, you can still do multiple remote statements, or you can pin up both tunnels. The client can have one WAN and still have a tunnel to each of the server WANs. And you could use like routing protocol or policy routing, whatever. All right, so moving on from the multi-WAN stuff, talk a little bit more about client-specific overrides. Client-specific overrides are entries that you can define that will change settings just for one OpenVPN user on like a remote access setup, or for one site on a site to multi-site type setup. The first thing you do is you pick which servers it's going to be active for, or if you leave it blank, it'll be active for all. You do need to be aware that if you're going to set a static address for a client, that doesn't make sense to select multiple servers, because that static address is only going to be valid for the tunnel network for one of those servers. It's not going to be valid for any more than one. So just be aware of that. The overrides are selected based on this common name field. If you've got a client VPN set up using just certificates, then you use the common name of the certificate. If it's got user authentication or certs and user authentication, then the username is what you match on. And there's another secret undocumented option that you heard it here only, folks, is that you can use uppercase default as the name for your common name, and that will set a default override setting for everybody, for multiple people. So you could have overrides for, say, 5 people out of a dozen, then have default for the rest. If you really wanted to, there are a couple of rare scenarios where that makes sense. Specifically, I can't remember off the top of my head what it was. We had a client that actually needed that not too long ago. I think what they did is they set common name default, and they blocked the connection to block everybody, and then whatever. But there's another way you can accomplish that I'll mention too. There's a CCD exclusive you can put in the advanced options that will block anybody that doesn't have an override defined. So, put in your common name, username, whatever you need to match by, and you can set it to block if you need to, but it's not a very good way to block. You should use a CRL if it's certificates, or you could shut off the username and password if it's authenticated. So your static address, like if you're trying to set a static IP address, if you're using ton subnet or tap style, you have to specify the address with the mask of the server. So like I said, like 10.08.99/24. If you're using net30 topology, you have to set the /30 exactly, like 10.08.224/30. So you need to be careful you're assigning the address, using the right syntax in that box. On OpenVPN 2.4, if your server has IPv4 and IPv6 tunnel networks both defined, you have to set a static address for both if you set it for one. So you can leave them both blank, that's fine. But if you define one, you have to define both. So if you can't have static IPv4 and dynamic IPv6 or vice versa, it's got to be either both dynamic or both static. The local networks here are routes on the server side. that you want to just push to this particular client. Like say you've got a management network that not everybody can access, and you can push a route to that network to these clients, and also you want to make sure you protect that with firewall rules. But so it makes sense that if somebody can't route to a network, you don't want to push that route to them. So it's better to not send that route out, and you can do it this way and accomplish that goal. The IPv4 and IPv6 remote networks, they set up what are known as iRoutes. So those are client-side networks that OpenVPN can reach by this client connection. So when you have a site to multi-site setup, each of your client sites has to have a unique certificate, and then you define here which LANs or local networks are reachable at that site certificate. So you put those networks in, IPv4, IPv6 remote networks, it'll set up the iRoutes and everything, but you do also need to have those set in the remote networks of the OpenVPN server. And if you want the sites to reach each other, you want to have those in your local networks box as well, so you're pushing those routes to your clients. So yeah, you can set it up that way. That's pretty handy for doing a site to multi-site, so you just have a single server. You don't have to have one server per client. And like I mentioned too, you can, on the server itself, you can put that CCD exclusive in the advanced options, and that will stop any client from connecting if they do not have an override defined. So that can be a good way to filter out, users that are valid for the VPN out of a larger set. That could also be used for ensuring a site to multi-site is set up properly to where you can have it set to only allow somebody to connect if they've got an override, because without an override, you're never going to be able to route back to their LAN. So it might be a little bit more obvious that something is messed up on the server side if you don't have that override in place. So that can be kind of handy as a connection verification tool as well. A couple other random things to look at too. Your OpenVPN servers can also be clients. So similar to IPsec, you can, clients can connect to servers, servers can connect to clients. This is only usable in static key or SSL's TLS/30 because in the others there's no defined relationship that would work. So you need to set your local port on the client to a static port like 1194 or whatever, and then allow that traffic on the client WAN rules. So sort of turn that into a server there. So you have a static local port like 1194 on the client. You let that traffic back in the WAN, from a source of your server, whatever. And then on the server side, you add a remote statement in the advanced options. And then the server can initiate to the client if the client didn't initiate to the server. So whichever one happens to connect first, it'll establish the connection. Or you could set up both sides of servers and add your remote statements that way. But the key thing is, got to use static key or SSL TLS/30 only. Both sides got to have a static local port and allow the traffic on the WAN rules. And then obviously the remote statement. Here's another little handy trick. You can sort of bridge without bridging. It's not bridging, but you can make your ton OpenVPN use a portion of your LAN subnet without bridging. Don't really recommend this, but it can work around some subnet related issues every once in a while. Like if you're having issues reaching a device on your LAN that doesn't have any special layer 2 requirements, but it wants you to be in the same subnet, and you don't want to add NAT or anything else to complicate it. So you can't do broadcast or multicast because it's not a bridge. But what you can do is pick an unused part of your LAN subnet. It's got to be something you can express as a CIDR network outside of your DHCP pool. So like over here on this one, I've got my LAN network here is 10.0.60/24, 10.6.00/24. And so my DHCP pool, I think on here is like 100 to 200. And so anything above that wasn't used. So I did 10.6.0.224/28. And that's just 16 addresses in topology subnet mode. That's still 15 clients, still a decent size. So I made that my tunnel network, and the next step you go to firewall, virtual IPs, and you add a proxy ARP type VIP for that same network on your LAN interface. So then that will have the firewall announce that, okay, this block of addresses are here on the firewall. Anytime somebody on your LAN tries to reach one of those, that traffic is going to come to the firewall. And so your clients on the VPN, they're going to naturally send that traffic through the firewall anyway, because you probably pushed them a route for your LAN subnet. And the more specific route will win. They don't exactly match, so it's not a conflict. This is similar to how PPTP used to work as being on your LAN subnet, but not really on your LAN subnet, so to speak. Basically, it's just faking it out. Just the proxy ARP lets your local network know that those things go to the VPN. VPN naturally knows to send it through. So it sort of works like it's connected to the same thing, but it's not. And so that can be handy in some situations. Just keep that in your back pocket. You may never use it, but it's nice to know it's possible. So your next option would be a complete tap bridge VPN if you want to go that way. We don't recommend bridging to LAN, especially for a site-to-site. You never want to do that for a site-to-site just because it's just going to make a mess of conflicts and multicast traffic and everything. But for remote access, it's not horrible, it's not great, but we don't recommend it. But there are some rare cases that benefit from it. If you've got some weird esoteric device on your LAN that requires multicast or broadcast to work, it won't talk outside of its subnet, and you have to get there. Like we've seen people use it. I think it was like a TiVo or a Chromecast or something that had to have a local access. So to make a tap bridge, very, very straightforward. It's just a lot of people get confused because they leave out a step here or there. You make your VPN without a tunnel network, like this one here. So similar to just a regular one, just you do not put a tunnel network in at all. Leave that blank. Leave IPv6 tunnel network blank. I selected bridge DHCP, and I picked the LAN interface. Now this doesn't actually set up a bridge. This just tells OpenVPN that I'm going to be bridged to LAN. Be ready for that. And then the rest of them are just like a standard remote access VPN. Nothing crazy about it. After you do that, you have to assign the VPN interface. So you go, up here, pick it, make sure it's assigned. Then you, under your interfaces, as usual with assigning, make sure it's enabled, got a description, IP type of none. After it's assigned and enabled, then you go back to assignments, over to the Bridges tab, and you make a bridge. And I've got my bridge created, and I've got my LAN and my bridge VPN selected, and then a save. And after that, you go back, you edit your VPN and save it just to make sure it gets restarted, just like you would do after any interface assignment or change. And that's it. Once you set that up, your clients will connect and they'll be bridged to your LAN. They'll pull DHCP from your LAN side DHCP, and it all just works. That's really all there is to it. One thing you need to be aware of, when you have a remote access VPN bridge to your LAN, it's not going to be able to push those remote network routes to your client because it won't know how to route them. So you will have to manually do route statements if you want in the advanced options. If you want to get out beyond your LAN to other networks, you can use the syntax I've got here. You push and then you quote route, and then wherever your route destination and subnet mask for the route, and then you have to put a gateway for them to use. Now that could just be your firewall LAN address. That could be fine, but they have to know a destination. And then after that, close the quote and that. So that will push that route statement to the client, and that extra parameter tells the client send this route traffic over VPN using this gateway, and then then they can get out and do what they need to do. A couple of the random tidbits that didn't fit in. You can do a port sharing between an OpenVPN instance and a web server. It is restricted to TCP mode, so it's not really great. But in the advanced options, you can put in port-share and then an IP address and 443. And the IP address is your local web server, like on your LAN or DMZ. So when a client hits that, OpenVPN will check. If it's an OpenVPN, then OpenVPN will handle it. If it's not OpenVPN, it proxies it back to the web server you specified. It does act as a proxy, so your source address is lost, and it requires TCP, so your VPN performance is going to be hindered. But as with a lot of other trickery with OpenVPN, it can be used to work around restrictions based on what you're trying to reach. So you can get to port 443 from a remote network, but nothing else, and you have to share port 443 with a web server. You could do it that way. Or if you're just trying to hide the fact that, hey, that's a VPN, it might help you there. But how well that works to fool anything these days is up in the air. But maybe once, if you do TLS crypt, maybe it might help. But I don't know if that, I don't know off the top of my head if that's compatible with port share or not. But it's a handy thing to, again, something to keep in your back pocket in case you need it in the future. Another change in OpenVPN on pfSense 2.3.3 and 2.4, they changed OpenVPN's routing so that it will drop packets destined for the server itself that arrive over OpenVPN. So if you're trying to get to like something on your server's WAN address and your server's WAN address was routed over OpenVPN, normally that would be a recursive route, and it allowed that before, but it doesn't now. If you need that behavior, you can add the allow-recursive-routing command on the client configuration. I think it just goes on the client, but you might put it on the client and the server just to be on the safe side. And lastly, there is a renegotiation seconds parameter that you can set. So we don't set it by default, but some client may assume a time there. So if you notice that a client gets disconnected, like after say a day or whatever, it's on a timer, you can play around with the value for that. I think setting it to 0 disables it, and you could just do renegotiate seconds and then or renegsec and then the number of how often you want to do that. So if you want to disconnect clients forcefully after like an hour, you could do renegsec 3600, whatever. So it's up to you if you want to do that. Okay, if you have any additional questions about OpenVPN, most of the stuff should be handled between this or one of the previous Hangouts. We had, just a couple of months ago, we did a Hangout on OpenVPN as a WAN for use with VPN providers. We also did one back in September, October of 2015 on remote access VPNs. It was a two-part one. I think the first part had mostly OpenVPN. The second part might have been mostly IPsec. I can't remember off the top of my head, but there was a lot of information back in that one if you're doing remote access VPNs. So between these three, pretty well covered just about anything you could do with OpenVPN. So if you have any questions, go ahead and type them out now. Let me know. Also, we're always looking for ideas for Hangout topics. If there's anything you want to see in a future Hangout, just let us know, and we'll try and get on the list if it's something that's viable. Let's see, somebody's asking a question. Any word on when or if OpenVPN will ever support multi-threading? It's a management nightmare to run a single server for every site just to manage the load. I don't know. I haven't heard any rumblings about that, but it's got a bit of overhead anyway with context switching, everything else. IPsec's always going to be faster if you're worried about performance, but OpenVPN wins on flexibility. But that's something you'd have to look in the OpenVPN project to see if they've got anything in their bug trackers about that. Let's see, somebody else mentioned, you mentioned Acme Let's Encrypt support, but there does not seem to be any documentation yet. And the question in the GUI is go to no help found. Is there documentation somewhere? There is no documentation yet. I am working on that right now. I've got a few notes. I just need to get them filled in, and I need to try a few more of the scenarios and get them well documented. I'm working on it. It's just not there yet. Somebody says, assuming a multi-WAN environment, I would like to route some clients to gateway A and the others to gateway B based on MAC address. Could you please explain how to do that? Well, you can't filter based on MAC address, so you would have to do something such as, assign them a static IP address based on their MAC in DHCP, like set them a static that way, and then, match those static IP addresses in your rules to policy route, A or B. But you can't just plain match by MAC address and do that kind of thing. It's got to be by IP. Anybody else? Any more questions? I know we ran a bit longer than I wanted to, but we had a lot of stuff to cover. So if you have kind of a longer question, sometimes it helps to just type something short and let me know it's coming. That way I don't cut somebody off. But any more questions? Going once, going twice. All right. So I think that'll do it for this month. If you have any more questions, anything like this, you can always post on the forum, or if you've got support, you can fire a question off to us on support, or you can reach out to us on Reddit, on the forum, on Twitter, wherever, and hit us up. Again, if you have any suggestions for Hangouts, drop them on the forum or wherever. Let us know one way or another, and we'll try to get them worked in. And we'll see everybody back next month. Thank you for attending.